we have a problem involving two triangles. We have a blue triangle stacked on top of an orange triangle, and we are meant to find the height from the base of the orange triangle up to the peak of the blue triangle that's stacked on top of it, kind of the apex of the structure. Now, normally with a problem like this, in at least trigonometry, you'd use the angles and certain sides of the triangle to determine this height. However, we don't know these angles, alpha and beta. In fact, we're not given any angles in here except these right angles. So we don't know alpha or beta. All right. Now, of course, this video is following up on our angle addition trig identity videos. So I would imagine that you're thinking it has something to do with that. So let's just pull up those formulas. I think it would be good to have them here, at least one of them. I'm going to pull up one of them, and it'll make sense why in a moment. So the sine of alpha plus beta, where alpha and beta are angles, is going to be equal to the sine of alpha times the cosine of beta plus the cosine of alpha, thank you, times the sine of beta. Why is my beta missing a patch? There we go. All right, so how could we possibly solve this problem? What can we set up that would lead to solving this problem? Well, what is h equal to, at least in terms of our alpha and beta? Well, h is part of this triangle here. You'll notice there's another triangle formed here, this right triangle. I'm going to kind of dot that out. I hope you can see that. There's that triangle there, and we know one angle of this triangle here is going to be alpha plus beta, and that the sine of that, so we know that the sine of alpha plus beta in our figure is going to be equal to our value h divided by 4, right? The opposite over hypotenuse. So we can simplify this a little bit in terms of how we're solving for h. We're going to have that h is equal to 4 times the sine of alpha plus beta. But we don't know alpha or beta, and let's say that we don't have a table of trig values or a calculator at hand. You know, not throughout history, the calculator, like TI calculators, haven't existed to solve all of your problems. And when you have something like this, it's good to know ways to work around difficulty. So we know, notice the figure, we know some lengths on this triangle. It's possible we can relate those to these sines and cosine values in the formula that we're given, and maybe we can simplify this further. Because of course, for sine of alpha plus beta, we can plug in what we have equivalent to it up here in the identity. So we have that h is equal to 4 times the sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. Get all of our parentheses in there. Great. So what are all these values? Well, we know that the sine of alpha is 5 over 8, right? Opposite over hypotenuse for this orange triangle. So we can write in 5 over 8 there. This is going to be 4 times. We're going to have 5 over 8. Now what's the cosine of beta? Ooh, well that's a value we don't quite know, right? Because we're given the opposite side and the hypotenuse, but we're not given the adjacent side. However, using the Pythagorean theorem, we should be able to solve that pretty easily. So I'm going to switch to a different color. We know, I'm just going to call that the adjacent side x. We know that x squared plus 1 squared is going to be equal to 4 squared. right? So 16 is equal to x squared plus 1, or x squared is equal to 15, x is equal to square root of 15. There we go. All right, so the adjacent side is square root of 15. The hypotenuse is 4. I'm going to switch back to white so that we can have some consistency in our lettering. So 5 over 8 times the cosine of beta is going to be square root of 15 divided by 4. You'll notice that's less than 1, as it should be. All right, now we're adding the cosine of alpha, another value we don't know. Well, we're about to know it. So let's switch to orange. Let's do the same thing we did for the last one. We know, I'm just going to call this y, this value down here, that adjacent value. We're going to have that y squared, oh, my pen is not cooperating. Y squared, our y disappeared. Y squared plus 5 squared is going to be equal to 8 squared. My equal signs just don't want to be written. So y squared plus 25 is equal to 64. So y squared is going to be, what's that, 39? So y is going to be the square root of 39, because it must be positive, of course. 39. All right, great. Let's plug that in. All right, so cosine of alpha, that's going to be square root of 39 divided by, what's the hypotenuse? 8, times the sine of beta, which we know is 1 over 4 from the drawing. Okay, now we can simplify this further. Let's combine some of these terms. We have 4 times 5 square root of 15 divided by 32 plus the square root of 39 divided by 32. I'm just going to pull those 32s out of there. We're going to have 4 divided by 32 times 5 square root of 15 plus square root of 39, or this is all going to be equal to 5 times the square root of 15 plus the square root of 39 divided by 8. And if for some reason you can calculate these square roots perfectly, but cannot do trig functions, if you somehow have a calculator that can do square roots but not trig, then you could solve this, but also square roots tend to be a lot easier to approximate than trigonometric functions. So using this would be our final answer, because I think this is about as simple as we're going to make it. But this would be our value for h. I'm going to actually write that here. H double equals. H is equal to. That would be our value for the height. Notice we didn't have to use a calculator to get here at all. We have a pretty simple answer. The only issue is we have radicals, which can be approximated pretty well without calculators. In the next video, we're going to be going over possibly a more common example of the use of the trigonometric angle addition identities, and we're going to be using the cosine identity. I hope this was helpful. Thanks for watching.